Welcome to my channel. Welcome to Industrial Electronics. So we have course outline for these subjects. So we have three major topics. So we have operation amplifier, voltage regulators, and thyristors. So when I was still teaching in electronics department in electronics technology, so we used to have two industrial electronics. So we have IE1 and IE2. So IE1 consists of voltage regulators and thyristors, whereas IE2 is purely operational amplifier. But as for you, since you only have one industrial electronics, so I have to comprise these two industrial electronics subjects into one. So that means you'll have two in one subject. So we have a lot in our hands. So I've already uploaded 3 PowerPoints, and then I'm going to share some books with you later on. But we have to proceed with op amp first. Okay? So don't worry. So I'm going to make it as simple as possible, as easy as possible. So if you have any questions, please contact me. You can write a message to me in my messenger if you have any questions. Okay? So let's get started. So first, we'll have some terminologies for operational amplifier. So in say operational amplifier, op amp for short. So in this topic, we are talking about 741 op amp. Okay, so we'll have that later on, but let's have some terminologies here first. So data sheet for the op amp. So we have supply voltage. So the supply voltage of 741 op amp can range from positive to negative 9 volts to positive negative 15 volts. So it actually has two supply. Okay, one positive and one negative. And then we have internal power dissipation, or PD. So this is the maximum power that the op amp is capable of dissipating at a specified ambient temperature. When say ambient temperature, so that is the environment temperature. Okay. Number 3. So we have differential input voltage. So this is the maximum voltage that can be applied between the inverting and non-inverting input voltage. So in differential input voltage, so that is actually the desirable voltage. And then we have the input voltage, or VICM, also called the common mode input voltage. This is the maximum input voltage that can be simultaneously applied between both inputs and ground. In general, this is equal to the positive supply voltage. So common mode voltage, common mode input, so generally referred to noise. Then you have the operating temperature, or TA, so ambient temperature for which the op amp will operate within the manufacturer's specs. The military grade operation usually has wider temperature rather than commercial. So commercial up to 70 degrees, industrial up to 85, military up to beyond 100 degrees Celsius. Output short circuit duration. So if you accidentally short circuited your terminal, so it should be able to withstand that short circuit without damage. Then we have the electrical characteristics. So we have static input parameters. Number 1, input offset voltage, or VIO. So typically 2 millivolts. So equivalent DC voltage that must be applied to one of the input terminals to produce zero output voltage with the other input grounded. So typically 2 millivolts. Number 2, so we have input bias current, so typically 80 nanoampere. So average of the two DC currents that flow into the inverting and non-inverting inputs. And then we have the 3, input offset current, or IOS, typically 20 nanoampere. So difference of the two input bias current whose polarity can be either positive or negative. Number 4, input resistance. So typically 2 mega ohm. This is the internal input resistance as seen at either the inverting or non-inverting input to ground, while the remaining input terminal is grounded. So typically 2 mega ohm. Okay, so next we have static output parameters. So output resistance of 741 op amp is 75 ohms. So you have a low output resistance. Okay. This is the internal output resistance as seen from the output terminal to ground. And then we have the output short circuit current or IOC. So this is the maximum this is the maximum DC output current that can be supplied to load. It is specified when the output is short circuited. And we have the dynamic parameters. So we have open loop gain, so also called the large signal gain. So voltage came to the op amp without an external feedback and varies with frequency. So typically it is 200,000 or 106 decibel or 106 dB. Then we have slew rate, the time rate of change of output with the op amp circuit having a closed loop gain of 1. So we have typical is 0.5 volts per microsecond. Okay. Don't worry about these terms. Okay, so we're going to explain it little by little as we go along with the topic. Especially if we're going to have the opportunity to have a face-to-face communication, so we're going to do it in laboratory. Third is we have the unity gain bandwidth. This is the frequency at which the open loop voltage gain decreases to 1 dB, to 1 or 0 dB. And then we have the common mode rejection ratio, CMRR. So this is a measure of the ability of op amp to reject common mode signals. So typically 90 decibels. So we have a formula here. So CMRR is equal to differential gain, so that is the AD over the common mode gain, so ACM. So the answer to convert it into decibels, so we have CMRR in dB is equal to 20 log of CMRR. And then we have the channel separation. So for channel separation, for packages having more than one internal op amp, so we have certain amount of crosstalk will be present. A signal applied to input of one op amp applied to the input. A signal applied to the input of one op amp section will develop a small but finite output signal in the remaining sections, even though there's no input applied to the unused sections. So we have for 747 and 5558 dual op amps. So when you say dual op amps, so you have two op amps in there, so it has channel separation of 120 dB. And for 4156 quad op amp, so that means you have 4 op amp in there, so you have 108 dB. But for 741 op amp, we only have one op amp in an IC. Then transient response, so we have the amount of time for the output signal response to an input signal to rise from 10 to 90% of its steady state value. For 741, so it is 0.3 microseconds. So we also have a formula here. GPP is equal to 0.35 of the TR. Okay, so this is what the 741 op amp looks like. So you can actually buy this in electronic store. Okay, just like it looks fairly just like your digital ICs. It looks like your 7400s, but the difference between those digital ICs, so we have 8 pins here. Okay, so you have to memorize the 8 pins here. Okay, so first pin is offset null. Second pin 2 is inverting input or the negative input. 3 is non-inverting input or positive input. 4, you have negative supply. So that means that if we're going to use a battery, so you can have it, you connect a -9. So if we're going to use a battery, so you may use two batteries, one for negative and one for positive inputs. Okay. And then for 5 offset now. Okay. So 1 and 5 are usually used if the output, if you have to make some changes to the circuit such that the output will be 0 if the inputs are 0. So if the inputs at pin 2, the inverting, and pin 3, non-inverting, are 0, so the output should be 0. However, there are times when, usually, there are times when the output is not 0, although the inputs are 0. So that's when you use the offset now. So 1 and 5. You connect a potentiometer across 1 and 5. Then 6 output, that is where the V out is taken out. So you may use either oscilloscope or multimeter, voltmeter. Okay. But I guess you would appreciate it more if you're going to see the output using oscilloscope. And then 7 positive supply. So this is your second supply, but this time you have to connect the positive to pin 7. So take note, 4 you connect the negative, and then the 7 you connect the positive. And then 8, no connection. Okay? So it really has nothing. So you can break the leg of pin 8. Okay. Okay, so let's have the first circuit for 741 op. So when I say non-inverting amplifier, so the op-amp, so generally this is the symbol used in amplifier. So generally use a triangle for an amplifier. So 741 op-amp is generally an amplifier. So when you say amplifier, so there should be a gain between output and input. So when you say gain, so generally it is a ratio between output and input. So since we're talking about the voltage here, so gain here is computed as V out over V in. Okay, so we have here, so this is a symbol for op-amp. So you have a triangle here, you have an output here, and then take note you have two inputs. You have a non-inverting inputs. So again, from previous slide, so non-inverting is pin 3 and this is pin 2. Pin 2, pin 3, and the output is taken across pin 6. So pin 2, pin 3, and pin 6. So this is generally the circuit for non-inverting. So take note that we have a feedback resistor here. So when you say non-inverting, it consists of input resistance connected to the inverting, and then the other end of the resistor is connected to the ground. Then we also have a feedback resistor connected to the inverting input and to the output. So this is pin 6. So you have to connect a resistor between pin 6 and pin 2. Then you have an input at the positive or pin 3. So that is non-inverting. So we have one formula for non-inverting is 1 plus RF over RI times input. So this is already a established formula. Okay. So again, I usually derive this, but for simplicity's sake, so this is the formula for non-inverting amplifier. Whether you like it or not, so this is the formula for non-inverting amplifier. 1 plus RF over RI times V in. Okay? Then let's proceed with inverting amplifier. So as you can see, we basically have the same circuit for inverting amplifier. So we still have the RF here, the feedback resistor connected from output pin 6 to inverting input at pin 2. And we also have internal resistor connected to pin 2 and to the ground. So what do you think is the difference between inverting and non-inverting? Can you guess? Can you guess the difference between inverting and non-inverting? Take note, aside from the formula, of course, you may say it's a formula. But again, for simplicity's sake, so inverting is negative RF over RI times V in. Okay? So what do you think is the difference between non-inverting and inverting? So please tell me the answer. Message me through MS Teams chat. Okay? The difference between non-inverting and inverting amplifier. Okay? So I have to get the answer until tomorrow. Next circuit, we have voltage amplifier. So voltage amplifiers V out is equal to V in. So basically just used to isolate one circuit to another. So we have, so what have you noticed in voltage follower? So take note, it has no resistors. Okay, but although it has lines that connects pin 6 to pin 2, and then you have pin 2 to the ground, but there's no resistor, so it's called voltage follower. So it just used to isolate the one circuit to another. Okay, so I'm going to wait for your answers. Okay? I'm going to upload this video and then wait for your answers. What's the difference between non-inverting and inverting aside from the formula? And then we'll proceed with discussion. Then we're going to have sample equations, sample problems using these circuits. Okay. So that's it for now. And I'm going to record the second session. But for now, I'm waiting for your answer. So what do you think is the difference between inverting and non-inverting? What have you noticed? So please PM me. Send me a message privately in MS Teams. So if you cannot go through with it in our, you have to message me privately. No cheating! Okay, so bye!